Hello, today we'll be going over the solution to the problem mowing the field from the 2017 January bronze contest. If you haven't already, I recommend you watch the previous video where I go over the problem and then give some tips to get you started. In this video, I'll go over the full solution. So basically the solution is that we're basically going to simulate the whole grid in which Farmer John is mowing. So we're gonna like represent the lawn in an array so that we can just keep track of where he's moving. So what I mean by that is if we have this grid right here, we can basically simulate his movement if we're given like the directions north 1, south 2, and then, right, actually that's not very, we can do east 2, and then south 3, and then, yeah, so assuming our start point is somewhere here just so we can visualize it better, we're gonna like read each line of input, which is gonna be north, so we're gonna go up in the, I guess, upward direction, and then we're gonna go one step, so we can go, this is basically our thing. But so since this is gonna be somewhat like a grid, let's just assume this coordinate is 0, 0. At 0, 1, which is where we're going to land after the first set of directions, we're going to keep track of the basically the last time we came here. So initially everything is going to be set to time, I guess you could say something like -1 because we haven't visited there. So our start point is going to be time 0, and then our next step is going to be at time 1. Okay, so let me just move this. And then once we get here, which is the coordinate 0, 1 at time 1, we're going to move to the next one, and it says east 2. So we're going to go 2 steps in the east direction or the right direction. So we're going to go 1, 2. So once we get here, it's going to be 1, 1. And we have to keep track of the last time we visited here, so it's going to be, well, the previous one was 1, so it's just going to equal 2. So we got to the coordinate 1, 1 at time 2, and then the same for 2, 1. We get there at time 3. Yeah, and then let's move this here. And then it's going to be the next one, which is south 3, so we're going to go 3 down. We get here, we're at 2, 0, and it's going to equal 4 at time 4, and then 2, -1, it's going to equal time 5, and then, yeah, just so that we don't have to go any further, actually going to delete that and just say it's 2. Okay, so this is basically what we're going to be doing, where for each point in our grid, or we can think of it as a 2D array, we're going to keep track of the last time we visited. So at the end, it's going to look something like 0, 1, 2, 3, 4, 5. And then everything else around it is going to be -1, -1, -1, -1, and so on. And so what are we going to do with this here? So once we have, once we've kept track of the last time we got here, let's actually add some new directions so we can visualize this. So we'll go back west 1, and then we'll go north 3. So we're going to go west 1, so it's going to equal 6, and then we're going to go up 3, so 7, 8. And so once we get here at 8, it's a little messy here, but we can see that at time 8 we're revisiting this, I guess, point in the grid. that we've already visited at time 2. So we know exactly when we last visited this cell, and so I guess you can think of it as the amount of time, or the minimum amount of time it had to have been for the grass to grow would just be this time 8 minus the last time we visited, or 2. So 8 minus 2 is 6. So we can basically think of it as because Farmer John said that every time he visits it, the grass will have grown, the maximum amount of time it could have taken is 6. So, yeah. So the process is pretty simple. We just follow the input, the directions, and the magnitude, and then in the array we keep track of the time for every move, because he moves one cell, or 1 unit per unit of time. And so we just keep track of the last time we visited the cell in the array, and then if we ever revisit an array, we can simply subtract the current time and the time already in the array and see how much time it's been since we last visited that area. And so now what are we going to do with this information? So we have that it's been 6, not sure if they give a measurement of time, but I'll just say 6 units of time. And we're trying to find the maximum that's allowed. So if we continue this process, let's just say it goes, let's say it goes up, or we can say it goes back down. So south 1. Let me just clear some of this. So let's just update it. So now at this point, this cell right here is going to equal 8 instead of 2, because we visited it recently. And then if we finish out the process, we go up again, so at 9, and then we go back down at 10. But if we look at this, we just came to this cell at time 8, but now we're visiting it again at time 10. So again, we can do 10 minus 8, which is 2. And this is the maximum amount of time it could have taken for the grass to grow, because Farmer John just visited it 2 units of time ago. And so what does this mean? So previously we had 8 minus 2. So we had 6 as the maximum, but now we have 2. So if we're looking for the maximum, we actually have to take the minimum between them, because if it took 6 units of time, then the grass wouldn't have grown by the time Farmer John came back to this cell right here. So we take the minimum of 2 and 6, and that's going to give us 2. And yeah, so in addition to keeping track of the grid, we also have to keep track of the, I guess you could say, the minimum of the maximum amount of time. So we can have something like answer, initially it has to be, I think it says it will not be greater than, or we can just say it's like some arbitrary, we can, or yeah, so it says it cannot exceed 1,000, so we'll set it to 1,001. And then all we have to do is just keep taking the minimum. So anytime we come across a cell that we've already visited, we can take the minimum between the current time and the last time we visited that cell, and the current answer. So in this case, we'd be taking the minimum between 10 minus 8, which is 2, and 6, which was the previous answer. That would give us 2, and we just repeat that process. And I guess 2 more things to point out. One, how do we tell if we've already visited a cell? Well, like I said before, everything is going to start out at -1. So if we've been to a cell, it's going to be an integer other than -1. So we'll know. If it's greater than 0, then we've already been there. And second, it doesn't specify which direction, or like the boundaries of Farmer John's movements, he can just go 1,000 units, I guess at most, because it's 10 times 100. So what this means is when we actually do the simulation of the grid, instead of starting at 0, 0, we're actually just going to start at 1,000, 1,000, because we can't deal with negative coordinates for the arrays, because the indices can't be negative. Or if you want to take a different approach, you could also just add 1,000 to every index you have. And yeah, that is basically the problem. So solution to the problem. So to recap, yeah, so we're going to create a grid of, I guess you could say 2,000 by 2,000 with -1 as fill. So you're going to fill a grid of size 2,000 by 2,000 with -1 as fill. And then you're going to simulate the movement of Farmer John and keep track of the time, and store the last time visited in each cell of the grid. If you visit a cell that's greater than 0, or you can say greater than or equal to 0, then take max of current time minus last visited time, and the current answer. So and yeah, that's the solution to this problem. I would go ahead and try implementing this by yourself, but if you're still stuck, in the next video I'll go over the coding solution. Thank you for watching.